welcome back to the Envision Home at Last video series. As promised, we were going to go on site here to talk more about framing. I have Rick with me again here, and we're going to really talk about the structure from top to bottom. So Rick, let's start here with trusses.
Sure. The first thing in good building design, Mark, is taking the loads that are imposed on any building and finding a way to get those loads transferred down through the structure into the foundation. Some of those loads that we're referring to start up on your roof. That's snow loading, going through the winter, the snow that's going to sit on top of that roof. One that people may not realize is wind loading. Windy days, when you've got a strong wind coming over the top of your house, it creates an uplift on your building. So we have to accommodate that. We also have to accommodate lateral forces from winds that act upon the walls. And the main goal in this design is to transfer all that loading down to the foundation properly. And that all starts up in the roof trusses.
So what are we doing? Give me some of the ideas of how we transfer that load.
You bet. So when we do the design of this particular roof or any roof, what we're trying to do is get our main roof loads to the outside walls. All your roof trusses are typically designed to transfer your loading from the roof down through the truss and out to each end of each truss, taking that through the wall system.
Now this would be a good example right here. We have a 2-ply truss, which we call a girder, and this comes across and it hits a double stud here, and we're starting to transfer this load down, correct?
Absolutely. This girder is creating what's called a point load. A point load is basically a concentrated load versus a uniform load that would be spread out along a longer distance. Anytime you create a point load, you have to support each ply of each truss, and we're doing that by a double stud, which will then transfer down and through the system down to the foundation, which we will show you later.
So as these studs go down and into the floor system, we pick up that load with what's called squash blocks, correct?
Yes, absolutely. Underneath this wall and buried inside this floor system, we've got LVL blocking in there now. So we're transferring it through the upper wall. Now the floor system's picking up that load. Then we're bringing it down to the next level. Okay. We just happen to be in a 2-story home right here. We're up on the 2nd floor, and we'll be working our way down.
All right, now we're down in the great room here with some volume ceilings. Rick, talk to us about these trusses a little bit.
Sure, what we've got here, Mark, are parallel cord trusses. Parallel cord truss is when you're looking for an extreme pitch on the interior side for your ceiling, and we're talking when you're getting into the 9, 10, 12 range, and your roof systems has the exact same pitch on the outside, basically meaning the ceiling is parallel with your roof plane. A couple things that play into having a parallel cord truss and getting those trusses to design properly is having enough heel height. When I refer to heel, what I'm referring to is at the end of the truss, it's the distance from the top of the wall vertically to where you meet the roof sheeting. With a parallel cord truss, it requires an extremely tall heel to get that truss to work. Previously, we discussed loads imposed on the roof system and how we transfer those through the building. We talked a little bit about a girder truss and picking up the point loads from a girder truss. Now I'd like to explain to you a little bit about what a girder truss is. A girder truss is simply a multi-truss member that supports other trusses. As we see here, we've got small mono jacks that have hangers that attach those trusses to the 2-ply girder truss, which will then transfer all of those loads back to the point load in this back wall, transferring that down to the foundation. As we continue to talk about our load transfer through the building, we come down to the basement to show an example of point load blocking and some of the beams and posts that it takes to transfer these loads. Above me here, up in the floor system, is an example of that point load blocking. The wall above it typically will have a 1, 2, or 3-ply stud in that wall, transferring that roof load and floor load down. We must be able to transfer that load through that block into the beam, through the post, down into the foundation. A common item in any basement are drop beams. What our drop beams allow us to do is support the floor system. Most floor systems, whether they're dimensional floors, a 2x10, 2x12, or an engineered floor system, need some sort of center support. Most of those floor systems cannot span from the front of the building to the back. And in order to accomplish that load bearing, we use an engineered LVL beam. In turn, we also need FHA posts to transfer those loads from that beam. Majority of your beams cannot go from end to end without having a steel FHA post to transfer those critical loads. Once those loads hit that steel column, they're just not hitting the basement slab. Beneath this basement slab is a built-up post pad, sometimes anywhere from 24 inches by 24 inches wide, even 24 inches deep. And those are the bearing members that carry all of that loading that starts up on our roof system.
Okay, so the last thing I want to talk about now is one of the most common structural items we come across in framing. So Rick, let's talk about headers above windows and doors.
Sure. As far as a header goes above any door, whether it's a garage door opening like this, a front door, a window in your house, the main purpose of that, again, is to transfer that load. That's that common message we're getting across, is we need to transfer those loads to the foundation. We're trying to avoid big sagging openings. That's the purpose of your header. In a worst case scenario, we're trying to keep the roof from collapsing and the wall collapsing. So properly sized headers above openings are extremely critical.
I think that wraps up all our framing issues that we come across both in design and on site. So Rick, thanks for your help today.
You bet.
I hope you like what you saw today. Please subscribe to our YouTube channel and visit us on our website at envisionhomeatlast.com. We'll see you next time.